All right, so now we're going to do it for carbon dioxide, determine the hybridization and draw the sketch of the molecule. So first we draw the Lewis structure. Carbon in the middle, two double bonds, and let's determine the hybridization. So we see that there are two bonded atoms and 0 lone pairs on the central atom. So that means that there are a total of 2 hybridized orbitals, which means we see a linear sp hybridization. That's our hybridization. So for this example, I'm going to draw the orbital diagrams for carbon after hybridization and for oxygen. And remember, in our class, we're assuming that the outer atoms are unhybridized. So I'll be drawing the orbital diagram for unhybridized oxygen. So for carbon, we know that sp means that there are 2 hybridized, I'm going to draw those a little lower, 2 hybridized sp orbitals. And each of these has 1 unpaired electron. And then we're also going to see unhybridized orbitals for an sp hybridization. We can see that up here, right? That for linear sp, there are 2 unhybridized p orbitals. In this case, they are 2p. And so we will see those unhybridized p electrons in our drawing. And for oxygen, also unhybridized. These are the valence electrons, right? 4 valence electrons for carbon. There are 6 valence electrons for oxygen. 2 of them are in the 2s orbital, and the rest are in the 2p. And so for oxygen, there are 2 2p orbitals with unpaired electrons. So those are the ones that are going to bond according to valence bond theory. All right, so first we're going to draw the hybridized orbitals around the central atom for carbon. Oops, oh goodness. Pardon me. So we've got carbon. I'm going to kind of give myself a little more space here. Carbon with 2 sp orbitals. Here's one hybridized sp orbital, and here's the other hybridized sp orbital. I'm going to draw each unpaired electron in there. All right. And let's also draw the unpaired, unhybridized 2p orbitals on carbon. The 2p orbitals are perpendicular to each other. I'm going to draw one coming out and going behind, and a vertical one as well. So these are perpendicular to each other. One's going behind over here and one's going straight up and down. All right, so now, and we'll see 2 valence unpaired electrons in the unhybridized p orbitals. Now, for oxygen, on either side, we're going to draw its unhybridized p orbitals as well. On the left-hand side, I am deciding to draw the p orbitals in a plane, in the plane of the screen. On the right-hand side, I'm going to draw the p orbitals. I'm deciding to draw them one in the plane of the screen and one coming out and away so that I can show the side-to-side overlap. So here, in one of the 2 p orbitals, there was an unpaired electron, for oxygen. I'm going to draw that unpaired, but now it's spin paired with the electron in the hybridized sp orbital for carbon. Now on the other 2p orbital for oxygen here, I've got another unpaired electron, and this is what is going to bond side to side with carbon. So we can show that here. This is side to side overlap. And remember that for the whole p orbital, that's where we're seeing the overlap. All right. And then for the other oxygen-carbon double bond, I'm going to make this look a little more three-dimensional here, right? We've also got one unpaired electron in one of the 2p orbitals for oxygen, so that's a head-to-head overlap. right there. And then we've also got a side-to-side overlap with the other 2p orbital, and this time I've just oriented it flat, like with this orbital coming out and this orbital going away. So we still have side-to-side overlap and spin pairing with the unhybridized p orbital on the carbon. Do we see the side-to-side overlap here in the p orbitals and here, as well as here and here? And that's it. That's how I draw my structure with my hybridized and unhybridized orbitals. Now we can label the sigma and pi bonds. So every side-to-side overlap is a pi bond, and every head-to-head overlap is a sigma bond. Here is a pi bond, and here is the sigma bond. So for each double bond, there's 1 sigma, 1 pi. Over here, the other double bond, 1 sigma, 1 pi. And the pi bond is side-to-side overlap of the whole p orbital, so it includes top and bottom as we're drawing it here. All right, there we go.